Solving a system of equations by substitution is a great method. It will work every time, but depending on the equations that you start off with, there can be some additional steps included in there. For instance, with example 6, neither of the two equations that we're given are solved for either x or y, meaning our first step would be to pick one equation, solve for either x or y, and then go through that substitution process. Or alternately, we can use a process that's referred to as elimination, or in some cases addition, because what we're going to do in this approach is eliminate a variable by adding the two equations together in a very particular way. To start, we'll label our equations as 1 and 2, and then in this case we'll take the second equation and multiply both sides by 3. This will give us negative 3x plus 8y is equal to 1 because the first equation hasn't changed at all. But now the second equation will become 3x plus 12y is equal to 39. Be very careful that you always multiply the other side of the equation by that value as well. It's a mistake that I'll easily make from time to time. But since we've multiplied both sides of the equation by 3, we haven't changed the value of the equation. We've just made the numbers look a little bit different. And we've made them look different because, in this case, once we add these together, negative 3x and positive 3x will cancel out with each other. That is, we've added these two equations together in a particular way that eliminated one of the variables. Then we'll add our y variables together to get 20y, and we'll add 39 and 1 to get 40. To solve for y, we'll divide both sides by 20, which will give us y is equal to 2. From there, we go back to either of the original two equations, doesn't matter which one, substitute in the value that we came up with, so we'll get x plus 4 times our y value, which is 2, is equal to 13, which will give us x plus 8 is equal to 13, or subtracting 8 from both sides will leave us with x is equal to 5. Meaning our solution in this case will be the coordinate pair 5, 2. Making sure you take note of which value is x, which one was y. In this case, we found our y variable first, but that still needs to be the second value in our xy coordinate pair. In example 7, we'll use the same approach. In this case, we'll multiply the second equation by negative 2, which means that our first equation will remain unchanged, and our second equation will become negative 10x plus 6y is equal to positive 28. And we've chosen to update in that way because now when I add negative 6y and positive 6y, those terms completely cancel out, leaving us with negative 3x is equal to 12, and then dividing both sides by negative 3 will give us negative 4. Now we can go back to either equation. In this case, we'll use equation 1, substitute in the value that we found for x, which will give us negative 28 minus 6y is equal to negative 16. If we add 28 to both sides, we'll have negative 6y is equal to 12, and then dividing both sides by negative 6 will give us negative 2. This means we found our solution as the coordinate pair negative 4, negative 2. The real trick to this elimination method is just identifying what to multiply the equations by in order to get a term to cancel out. Example 8, in my opinion, is the trickiest case of this because there's no really kind of clear, easy choice to make. 10's not a multiple of 3. 8's not a multiple of 6. So there's no whole number that we can just multiply across one of the equations to get something to cancel out. In that case, what we'll do is just look at the coefficient. We could start with the y variables. I just tend to start with the x variables. And we'll multiply each equation by the other coefficient. So that is, we'll take equation 1 and multiply it by -10, and take equation 2 and multiply it by -3. The last thing we need to do before we multiply then is just change one of those signs. Again, it doesn't matter which one, but we're just taking the coefficient from the other equation, multiplying that through on both sides, and then we just need to flip the sign of one of those before we do that. Because when we do it like that, we'll end up with -30x plus 60y is equal to 180, and 30x minus 24y is equal to 0. So that process, why we multiplied the way we did, is so that in this case, our x terms will cancel out, leaving us with 36y is equal to 180, and then dividing both sides by 36 will give us y is equal to 5. Going back to either of the original two equations, we'll use equation 2 this time around. We'll substitute in y equals 5, and then solve for x. This will give us -10x is equal to -40 once we move that term over, and then dividing by -10 will give us x is equal to 4. Just like in example 6, we found our y coordinate first, so we need to make sure that we pay close attention to which variable is, or which value is x, which variable is, or which value is y. So our xy coordinate pair, the solution to this system, will be 4, 5.